Welcome. This is 9.2. Which statistics are most affected by outliers, and what shapes can data distributions have? That's what we're looking at today in this unit. First off, we're going to look at line plots. This is just some data that I got a hold of. Annual salaries in the thousands for these employees. And I wanted to do a line plot with it. So there's one at 25,000, one at 30,000, three at 35,000, three at 40,000, two at 45,000, one at 50, and one at 60. When I run my stats in my calculator, I get that the mean is 40, the median is 40, the range is 35, the IQR is 10, and the standard deviation is 8.9. Now, if you are saying, how did you get all those? Go back to the first film, 9.1, and look at that first. Okay? So, when we do a line plot, we just kind of want to make a general statement about the shape. We've got, looks pretty, it's a little bit more of a tail out this side, but it looks pretty even as far as being symmetrical. There is a separation right here between the bulk of the data and this 60,000. But it's a pretty good, just even symmetrical hump separation at the 60. So that's basically all that I would need to make sure that we've discussed as we look at that data. In data, there are two different types that I want you aware of. Quantitative is what we deal with a lot in our class. It's measurements, amounts, numbers. It's easy to apply arithmetic operations to the data. Qualitative is more what you'll deal with in some of your psych courses and some of the courses where you aren't just looking at raw numbers to be able to manipulate. It's information that's unable to be measured, like it's the judgment of relevance, a judgment of effectiveness, a judgment, like even the softness of, like, say, a cat, the softness of hair, or the color of something. So the color of the sky, you know, it's stuff that you can't necessarily measure. An outlier, by definition, an outlier will be a data point that is less than your first quartile times 1.5 times your IQR. Now, if you remember the data last time, we'd line it up, we'd find the median, and then we'd tick off to find the third quartile, tick off to find our first quartile. And what I'm saying here is that whatever this IQR is, whatever distance that might be, you're going to take 1.5 times it, or you can take the measurement of it, go 1.5, and if that data point lies outside of that, then you know it's an outlier. Or you can take this 1.5 times and go this way, and if it's 1.5 times the IQR out above the third quartile, then it's an outlier. Okay. So if we come back to this data, our median was 40, our IQR is 10. So 40, and an IQR being 10 means that it's centering right here around it. Now, in order to see if this is an outlier, we would go 1.5 times our IQR, which is 10. That's equal to 15. 15 plus 45 is actually 60. It's not greater than that, so that's not an outlier. It's actually on the edge of it. If it was 65, it would be an outlier. Okay? So you understand a little bit how it works. Okay, now we go back to the same company a year later, and they've hired somebody with a $150,000 salary. And so it changes their data a little bit. Now we've got this symmetrical hump like that, and then it goes way out here and there's a little hump. This is an outlier. Clearly, after I just showed you what the cutoff would be for an outlier. Okay, so now when we recalculate, look at what that outlier did. The mean became 48.46. Before, the mean was 40. So the change in mean has gone up by 8.46. The median is 40. Before, it was 40, so no change. The change in the range. Now it's at 125. Well, you can imagine you're going from your highest to your lowest. And here, it was at 35. So we have an increase of $90,000. Change in the IQR. The IQR here is 12.5. Here it was 10, so it's only up 2.5. Change in the standard deviation, it's now at 30.53. Before it was at 8.9. Ooh, I'm going to have to do that. 30.53 minus 8.9. 3, 2, 9, 15, 6, 1. It's up by 11.63. Now let's look at these. The median had no change, and the IQR had very little change. Remember that the IQR is found just like the median. It's found based on the order of the numbers and finding the locations and the spread of those. So by adding an outlier, we haven't changed these too much. The mean, it makes sense that the outlier would affect it a lot because you add it in to the other numbers and then you divide by that, you're going to have all of this up here. And does it make sense to you that the standard deviation would also be affected since you are subtracting the mean from every data point, and then you're adding that difference. So you've subtracted your mean from that 150 and adding the difference. So the mean, the standard deviation, and the range are all greatly influenced by an outlier. What does this really mean? Well, the first thing that I would say for you, what it means is in your grades, if you have an outlier, let's say it's 0, you need to look more at your median and at your IQR than at the other things. In actuality, that's what I do when I go to parent conferences, is if I see an outlier at 0, then I'll oftentimes switch over to looking more at your median and at your IQR to discuss your abilities in math. Now, if 0 tends to be common, then it no longer becomes an outlier. I mean, if you had 4 or 5 up here at 150, all of a sudden you're changing your median as well. So if you have 4 or 5 zeros, you're changing your median as well, and then we can't talk about your ability being higher than that 0 level. So remember that. When you get 1 0, it may not be all a wash, but when you start repeating that pattern, it begins to stand for who you are. Why are mean and standard deviation more affected by the outlier? As I explained, the mean, you're adding all the data points, dividing by the number there are, so it has a direct influence. And the standard deviation, remember the first step is to subtract the mean from each data point. So again, that outlier is getting into the calculations. Which statistical measures do you think should be used with outliers? Median and IQR, they're the least affected. You will have a question like this on the final. You'll be given data and you'll be asked which measure of central tendency or which measure of spread should you use for this data. You need to look and decide, does it have an outlier? That is a very common standardized test question, and you have to explain why. So now here's the shapes of data, the distributions. If you have a line plot where it looks like this, we say that it's skewed left because what's occurred is there's a dip on the left side. So it's skewed from the left. When this occurs, your mean will be less than your median. Okay? That means you might want to look at which you use to represent your data. When it's symmetric, like the first one that we looked at, then your median and your mean are generally equal. Okay, so you could use either one in that situation. Usually we go with the mean. Skewed right means that you have a dip in the right-hand side of your data, and in this case, your mean will be greater than your median. And that should make sense for the fact that your median's just skewed one way or another by that lump of data. Okay? And your mean is affected by these that are setting over to this side. Your mean's affected by these setting on this side, and your median is more in the cluster of the group. Okay? So I hope that helps you. We'll see you in class.